This question discusses the application of Newton's second law, which is always applied to the accelerating system. You can see here a elevator or the lift that carries a load and their combined mass is 750 kg. And what we need to calculate in this question is the force of tension in a cable. So the tension in a cable is in this direction. And provided information is that the acceleration is downward, and that acceleration is, I would say, negative 2 meter per second square because of its direction. Otherwise, the magnitude is 2 meter per second square. Now, this downward acceleration means that the system's weight is more than the force of tension. But we need to calculate the tension in a cable. At the end of the video, I will compare this scenario with this scenario if you are in a lift and how your apparent weight changes. So you should solve any forces question by first of all drawing the free body diagram. And I'm supposing that this is a system. System contains a load and the elevator. And the force of tension is obviously upward. So this is the tension in a cable. So this is a force of tension D, and the weight should be downward and it should be more than. So I will draw the lengthy arrow. So let's say it is mg. Now the second step is always to write its equation by using Newton laws of motion. And since it is accelerating downward, so we should use Newton's second law. So according to Newton's second law, F is equals to ma, but this F is the resultant force. So that's why I'm writing it F net, the resultant force. And in our case, since the mg is more than the force of tension, right? So you can write this equation like this: Ft minus mg is equals to m into negative a. Otherwise, you can also write mg minus Ft is equals to ma. So we can find out the value of force of tension. The force of tension in a cable will be equals to mg minus ma. So the weight of the elevator is 750 times 10 minus 750 times 2. So this is a force of tension in a cable. And its answer is 6000 Newton, which you can also write 6.0 kilo Newton. So that's why its answer should be option B. Now, let's quickly compare this situation. So, for example, if her mass is 50 kg, so her mg value should be equal to 500 Newton. So that is called the real weight. Now, so if she accelerates, she is in an elevator and the elevator is accelerating down with negative 2 meter per second square. So then the bottom scale, this weight measuring machine, will not read 500 Newton. Apparently, her weight will be decreased. And how much is that? So in this scenario, the force is the normal force applied by the machine, and this is her weight. So so the normal force minus mg is equals to negative ma, and the normal force is equals to, because this normal force right now is its real, apparent weight. So you can put the value and find its answer. That will be obviously less than 500 Newton, because when this elevator is accelerating down, so she is not able to press the machine with such a amount of force, with such a strength, because the machine, elevator, and everything inside is accelerating down. So she is unable to press down the surface of the bottom scale. So that's why the bottom scale will not read its that value of the normal force. So that will read the force less than 500 newtons. So this is happens in the accelerating system when your real weight is not equal to your apparent weight.